GeopByte.
Similarly, look at the another important question asking like this. A block of mass 10 kg is in contact against the inner walls of a hollow cylindrical drum of radius 1 meter. Radius of the drum is given 1 meter. Mass of the block kept in the cylinder, hollow cylinder is 10 kilograms. Okay. The coefficient of friction between the block and inner walls of the cylinder is zero point 0.1. Coefficient of friction mu equal to zero point 0.1. The minimum angular velocity needed for the cylinder to keep the block stationary when the cylinder is vertical and rotating about its axis will be. What should be the angular speed? Minimum angular speed should be maintained to maintain the static condition between the rotating cylinder and the block. It is like this. This is the right. Otherwise, let us take another slide. This is the hollow cylinder. In this hollow cylinder, a block may be kept somewhere here. The cylinder is rotating, but block is not moving. This is the block. That block weight is acting vertically downwards. That weight must be balanced by frictional force. This frictional force F equal to what? Mu into N. Mu into N. F equal to mu into N equal to what? M R omega square. M R omega square. Then this mg must be equal to F equal to, look at the F value, frictional force, mu into M R omega square. Here M part is cancelled. G equal to mu into R into omega square. From this omega square equal to G by mu R. Therefore, angular speed omega equal to root over G by mu R. It is equal to root over G value 10. Look at the mu value, right? Mu value is zero point 0.1, R is 1. 0.1 into 1. 0.1 into 1 is zero point 0.1 only. It is 10 by zero point 0.1. Therefore, omega equal to root over 100. Root over 100 equal to what? 10 radians per second. That is the minimum angular speed that we need to maintain the static condition between the rotating hollow cylinder and the weight which is liquid at the inner walls of the hollow cylinder. Okay, 10 radians per second. Look at the options. Look at the option C. Option C is absolutely correct. Understood clearly? Yes. Similarly, let us take the another important question. Okay. Look at the screen. It is asking like this. A mass M is attached to a thin wire and rolled in a vertical circle. The wire is most likely to break when option A, the mass is at the highest point. The wire is horizontal. Option C, the mass is at the lowest point. And D, inclined at an angle of 60 degrees from the vertical. Dear friends, remember, by the time the mass reaches to the bottommost position, the tension developed in the string is maximum. Therefore, the wire is most likely to break by the time the mass reaches to bottommost position like this, lowest position like this. It is like this. So look at the mass. By the time it reaches to lowest position, the weight is acting vertically downwards, mg, and tension developed is maximum. Because of that maximum tension developed in the string, that string or wire is most likely to break. This is the wire. It may be wire or string. Therefore, option C is absolutely correct. Okay, it is concept oriented question. This concept already we have clearly discussed while we were discussing the theory concepts. Do you remember or not? Yes. Then look at the another concept oriented question. It is asking like this. Which one of the following statements is incorrect? You are asked to decide the wrong statement. Option A, frictional force opposes the relative motion. Absolutely correct. Though that is the correct, that is not our option because wrong statement is our option. So this is correct statement. Limiting value of static friction is directly proportional to normal reaction. Yes, limiting force of friction equal to mu n. From this, limiting force of friction is directly proportional to normal reaction. This statement also correct. Similarly, rolling friction is smaller than sliding friction. Absolutely correct. The rolling friction, you try to remember that point. The sliding friction is very high compared to rolling friction. Okay, for the rolling friction, we are using the ball bearings, right? Ball bearings, right? Contact surface, when the two surfaces are contacting, where the friction is very high. Look at the option D. Coefficient of sliding friction has dimensions of the length. No, coefficient of sliding friction has no units because from this the coefficient of friction equal to force divided by normal reaction. Force is in Newton. Normal reaction is also Newton. It is having no units. No units. Here this is the Newton. Newton. This is also Newton. This N is normal reaction. This N is normal reaction. Okay, anyhow, coefficient of sliding friction has no dimension. This is the incorrect statement. That incorrect statement is our option. Therefore, option B is absolutely correct answer. Understood clearly? Yes. Similarly, let us take the another important question. Try to read it clearly. It is asking like this. A block of mass M is placed on a smooth inclined plane. Look at the smooth inclined plane. This is the smooth inclined plane. Let me write it. This is the smooth inclined plane. This is the smooth inclined plane. Inclined plane. Okay. Now, ABC of inclination, theta as shown in figure. Angle of inclination or angle between the base and plane is theta degrees. This is the base. Okay. Now, the wedge is given an acceleration towards the right. The wedge is given acceleration towards the right. The relation between A and theta for the block to remain stationary on the wedge. Though some force is applied on the wedge, the block is under stationary condition. So for having the stationary condition, what is the relation between the acceleration and the angle between the base and the plane? For that, first let us take the components of weights. Weight is acting vertically downwards, mg. Let me mark the normal reaction. This is the normal reaction line. Then this is the theta. Since weight is acting at an angle, theta with the normal reaction, it is developing two component of weights. This is the mg cos theta and this is the mg sin theta. Okay. Now here the net force is acting horizontally. The net force is acting horizontally like this. The net force is MA. This is making, right? It is making an angle theta with respect to what plane, developing two components of weights, right? Two components of MAs. Then this is the MA, right? So this is the along the plane MA cos theta and perpendicular to the plane. Perpendicular to the plane is right towards the mg cos theta. This is the mg, not mg, ma sin theta. Ma sin theta. Ma should be very careful. It is ma sin theta. Ma sin theta. Here MA sin theta and MG cos theta both are in the same direction. Anyhow, to have the no motion in the block, this MG, this MG sin theta must be equal to MA cos theta. Both are acting in the are along the plane in the opposite direction. Therefore, here I can write that this MA cos theta must be equal to mg sin theta. M part is cancelled. A into cos theta equal to g sin theta. G sin theta. From this acceleration equal to g times the sin theta divided by cos theta. As you know, sin theta by cos theta equal to tan theta. Acceleration equal to g into tan theta. That is the relation between the acceleration and angle between the base and plane. Look at the option D. Option D is absolutely correct. Understood clearly? Yes.
GeopByte.